Assalamualaikum and hi everyone. I'm Aliza from Faculty of Civil and Environmental Engineering, University Tun Hussein On, Malaysia. Today I want to discuss on topic 4, non-uniform flow in open channels. There are subtopics in this non-uniform flow that we'll discuss here are rapidly varied flow, gradually varied flow, and calculation of GVF profile. For the subtopic, there's a rapidly varied flow. 4.1.1 is a hydraulic jump, application of hydraulic jump, types of jump, momentum equations, conjugate depths of equations, and energy loss. For the gradually varied flow, there is types of slope, classification of GVF profile, analysis of GVF profile. And for the calculation of GVF profiles, there are direct integration, numerical integration, and direct step method. Okay, for the rapidly varied flow, occur when the depth of flow changes rapidly within short distance. Example for the hydraulic jump. Okay, we can know from this figure, hydraulic jump occur using from the supercriticals to the subcriticals. Okay, for the hydraulic jump here, we can know between the supercriticals and the downstream flow becomes subcritical flow when Y2 is more than YC and YC is more than Y1. Okay, hydraulic jump only occurs if the upstream flow is supercriticals, when Y is less than YC and the downstream flow becomes subcriticals, when Y2 is over than YC and over Y1. This figure shows the hydraulic jump in the laboratory flow. Okay, for the application of hydraulic jump, okay, first, energy dissipation, reduce velocity and prevent erosions. For the rest, the water level for irrigation or water distribution purposes. Increase weight on apron by raising the depth of water and mix chemical substance and also the aeration of flow. Okay, there is a types of jump. Okay, based on the Froude number. Okay, from the Froude number 1, if the Froude number is between 1 to 1.7, there is undulate jump. And when the Froude number is equal to 1.7 to 2.5, is a weak jump. And the Froude number 2.5 to 4.5 is oscillating jump. And when the Froude number is 4.5 to 9 is a steady jump. And more than 9 is strong jump. Okay. Okay, for the momentum equations, there is a equation for the momentum equations. It's consider a hydraulic jump on a frictional flat bed with a rectangular channels. Okay, let we see at the figure here. Okay, and the other after that, we can conjugate depth equations. Okay, you can look for the equation here for the hydraulic jump to occur when Y2 over Y1 is over than 1 or Y1 over Y2 is less than 1. Okay, for the energy loss, there will be considerable loss of energy and hydraulic jump between section 1 and 2. So from this figure, we know that when Y1 is supercritical at section 1 and to the section 2, so the energy loss is calculated as these equations. Okay, for the gradually varied flow can define as a steady non-uniform flow in prismatic channel with a gradual change in this flow surface elevation. Example here is when the drawdown produced by sudden change in channel bed slope. Okay, so for the backwater produced by increase in the bed elevations, we can see from this figure. Okay, this is a types of flow. Table shows the types of flow between Y node and S node. When the type of flow using the symbol M, S, M for mild, S for steep, and C for critical. and H is for horizontal and A is for adverse. Refer to the figure and we can know that profile occur for mild, steep, critical, horizontal or adverse based on the determination of flow depth Y, Y0 and YC. Okay, all curves in region 1 have positive slope. That's why the backwaters curve, all curves in region 2 have negative slope. It's called a drawdown curve. Okay, for the analysis of GVF profiles, there are two basic assumptions are involved in the analysis of GVF. Okay, one, the pressure distribution at any section is hydrostatic. The resistance of flow at any depth can be assumed as uniform flow equations using the Manning equations with the condition that the slope term to be used in the equation is the energy slope. GVF, the depth of flow at any section is Y, the energy slope SF is using this equation. Okay, for the calculation of GVF profile, we can use using the direct integration, okay, numerical integration and direct step. So we can look from this figure, gradually varied flow surface, we can calculate using these three methods. Okay, for the direct integrations, we will use these equations. And for the numerical integration, we will use this equation based on all sections, rectangular, and very wide channels using the chassis. Okay, and for the direct step methods, we will use this between two sections and these equations. Last but not least, at the end of this topic, students should be able to analyze the characteristic of hydraulic jump, rapidly varied flow based on momentum equations, and analyze the characteristics of gradually varied flow. Okay, that's all. Thank you.